Hello, everyone, and welcome back to Handmade Hero, the show where we code a complete game live on stream. We have been away for a while, but, there's nothing in particularly magical about being away for a while. Oh, except for the fact that apparently we need to figure out why our forecoder isn't building. Other than that, we're fine. Looks like as long as I'm in that directory, it works. All right, who knows? Anyway, when we left off, we had just modified the tag system. I think we still maybe had some debugging we wanted to do, but we had just changed the tag system over to something simpler. We're basically at the point now where, most of the things we need to do are for the most part done. And we're really just trying to figure out like what sorts of stuff we want to be doing with gameplay. And so we're kind of going through and just trying to make sure that we have a decent sort of setup where everything is kind of a streamline for putting gameplay in. And I don't actually know what I thought we had a little bit of debugging to do left on the tag update. It's working, but I think there were still a couple things in there that weren't right. If I run it in retail mode now, let me just see if I'm right about that. Yeah, so okay, like we saw some stuff like that we had not seen previously. Like where the lighting gets screwed up, right? I remember some of this now. It's all coming back to me now. So there's some weird things in here, like, the lighting just kind of stops working properly for no good reason, right? We don't have an explanation for that. And it sometimes works and sometimes doesn't. So there's like something where we like something isn't getting loaded properly. We don't know, right? Like we just don't know. We've got a bug though. And you can see like that kind of weirdly there, like it seems like when we run in debug mode, we don't have this problem, right? So here's like me running in debug mode, and you can see that there's nothing weird going on with the lighting. And so something's up, right? We've got a weird bug because the lighting is in debug mode. We don't see any weirdness, right? It looks like what you would expect it to look like. So we know that something bizarre is happening here. And the question is, what? We've got to figure out like what we broke when we were messing around, or it could be that we didn't break something when we were messing around. That all we did was like uncover another bug that that had just been lurking. And what we're seeing here is the manifestation of a bug that otherwise would not, was kind of hidden or something, was masked by something that we were doing previously. And then when we kind of jiggled things around, we ended up in a situation where we couldn't actually, where we didn't actually get it to work. Now, here's another thing, right? Like, where's that guy? So that's another tag bug we have, which is presumably that the, and also the down one doesn't work, right? So we've got a bunch of bugs in the tag stuff that we ported. And so really probably all we want to do today is just get back into it and go fix those bugs. So try to get these sort of weird bugs we introduced back out of here, which is probably mostly about streamlining what we've done and cleaning up any rough edges and looking for, mistakes, the mistakes that were made. Because it is weird that works in debug but not release and so on. Like, that's just kind of weird. So that there's something funky going on, if that makes sense. All right. So let's take a look at, first of all, maybe some of these basic tag situations. So we kind of had when we were creating those monstars, we know that there should have been like a little skull with the monster. So maybe the easiest thing for us to do first is just take a look and see why we're not getting any of those monstars anymore. So if we take a look at where those are being added, you can see that we've got sort of this create entity stuff going on. And I believe that the enemies are added via this routine, right? So, they get added, much like the cat and the orphans and so on. They get added by these little callbacks that just like build little creatures, right? They build whatever. Sorry, I got to turn that off. Battery. There we go. We're still in a weird place with 4Coder right now, waiting for Alan to update it, or maybe he has. I haven't heard from him, so I'm not sure what the status is. But there's a couple weird things that are just kind of waiting for a 4Coder update, and I don't really know what the status of because I haven't been programming in it. As you know, I've been away. So if we take a look here at, I think add snake is what's going on, and right now those are technically snakes. They just don't have multiple pieces because we're just, when we put this in, we were just testing with that. So this right here is what should have been working. This is what should have been creating the snake head, which is this asset head piece here, right? And then we have this base asset, which was a thing that should have been passed in, and it's like what kind of snake you wanted it to be. And so presumably the problem here is that when we did the add snake, we ended up in a situation, add snake. We ended up in a situation where whatever the base asset was not correct somehow. So you can see here that it's got a tag bones on it, and other than that, it doesn't look like it has anything else. So I don't actually know what those bones things were, but it could be that we just need to add the other tags that we need to specify the sort of head piece skull thing. I don't know, whatever you want to call that. So I'm going to go ahead and look for that. We don't want mummy, so it looks like undead is probably was the thing we wanted there. So in terms of this is undead bones. So I assume you want like that kind of a thing. And I'm just gonna see if this makes that part any better. And so off we go to the, wow, that is a weird, that lighting stuff is very strange. I'm gonna be interested to see what's going on with that bug, but we'll see. So off we go, hopping down to the, you can tell it's like an overflowy kind of a situation, but there's our fellow there. So it looks like the problem that we're having, now we've got the skull is fine, so that's all good. But it looks to me like the problem we're having, the last thing I can see that's obviously wrong about the tags is that as we're moving around here, the downward facing direction tag is not looking up properly. Well, it's not really a tag, it's more of a number. So the downward facing number is not working. And you can see that both in terms of the hero. So if I punch in any direction, you can see the hero switches to facing that direction, except for down, right? The hero's sprites don't change direction for down. And you can see that that's also true of like the skeleton. So the skeleton changes to face the direction the skeleton's hopping, but never for down, right? So we know that the down directional, like, whatever you want to call that, the downward facing direction is not working, but we don't necessarily know why. Now, it probably has something to do with how we're mapping the numbers, but who knows? So let's take a look and see what those numbers actually are, or what they should be. The downward facing one is the one that is basically the furthest all the way around. So you've got 0 is facing to the right, I believe is how we do it. So 0 is facing to the right, pi over 2 is facing up, pi is facing left, and 3 over 2 pi is down, right? I think that's how it was done, but I don't remember. It might have mapped 0 to 1. I have no idea. So we also do it cyclical, so if you keep going past 3/2 pi plus 1/4 pi, which would be 7/4 pi, I guess. If you go 7/4 pi, you would get a wraparound back to the 0 direction, right? Because it's, we wanted it to be cyclical so that as you got back around, that's where you would go. And I don't actually think that would be implicated here, although if we screwed up that calculation somehow, then it could be. So we can probably debug this pretty easily by just looking at the selection process for it. However, I just want to look at that routine first because I want to familiarize myself, because we haven't looked at this code in a while, with just like what we ended up deciding to do here. And you can see, so here's the routine that actually looks for assets. So what it does when it comes in here is it asks for, based on the hash, so that's the thing that says like, oh, this is like an undead whatever, right? Is you can, in here, you can go ahead and grab like that series of sprites, which is just the different facing directions or whatever. And then it'll go through here, it'll look through the slots, and it'll try to match whatever the match vector is. And the match vector is the thing that actually has... Oh, weird. Why is my CPM so high? What's going on? Are we in power mode? Oh my god. Ryan, how are we in power mode right now? I haven't even been typing. What's going on? What? Power mode should not be implemented yet, should it? Well, I do like power mode, but we're gonna have to sideline it for now. Sorry, folks. F4 power mode disallowed. That breaks my heart, turning off power mode. I don't mind telling you. But everyone, you can blame Ryan. He's on the chat. The power mode. I did my part. The sound plays back correctly for power mode. So I consider myself blameless here. The CPM counter, that was Ryan. So I'm just saying, Ryan. This is what happened there? What happened? Right? The CPM decay not working. That was out of my purview. I think we all agree that power mode is a critical feature and that there's no way we can finish Handmade Hero without it. So I don't want to say that everything's riding on you, but everything's riding on you. Okay. So what we're seeing here is just that we're getting some kind of a problem with matching these directions. And you can see here the way that we're doing it is we're doing this absolute value differencing nonsense here, right? To try and match the circular pattern to the correct series of things. And, this is, I think what happened, if I remember correctly, is I was like, well, this is dumb. We shouldn't bother doing this. We should just match linear. And then I was like, well, let's keep using it, whatever. And all that was stupid. Because honestly, I'm not sure why we don't just add a duplicate reference to the asset at 2 pi. Because that would just solve the problem, right? And then you wouldn't need what's going on here, right? You just add the asset twice. Now, maybe there's some overwhelmingly obvious reason why you don't want to add an asset twice. And I mean, if I went and looked at the code, I might find that, right? And if that's the case, then you can see why we need to do this range-based mapping here. But it feels to me like we could probably eliminate this entirely just by adding that additional feature. Now, what I want to do first, because I want to start removing pieces of this problem slowly, is I'd like to get rid of the range mapping, because I want to start by just looking at the basics here. So I want to say that let's just do this first. In fact, let's just do this. And I want to get rid of that range mapping, and then I want to see if we can maybe just remove that range mapping entirely, because it's just extra stuff that has to happen for no reason in there. And so because we already have a bug in that stuff there, I don't anticipate any problems with this, because, I mean, hey, we've already got a bug there, so we shouldn't see any, and it looks all fine to me, right? So it looks like there's nothing weird happening there in particular, right? So that all seems fine. So I'm going to go ahead and say that we can just yank this, and then we can go see what's going on with that circular system to find out why we're not getting that final match that we expect to have. And we can add one more at the rotation point if we need to. We may never actually need it, in which case we can just ignore it entirely. So what we would basically do is push this out of here. The difference part here would now take this D0, and it would put that in here, right? And the only problem that we would have is we have to map this 0 to 1, so it wouldn't be 0 to 3 to 2 pi anymore. I don't know to what extent that matters, but in order to make this always work properly, we would want to make sure that we always tracked the difference that way. So I'm going to go ahead and say that's what we're doing here. I'm going to pull that tag range stuff out, because I haven't liked it for a while, and I kind of chickened out on pulling it before, but we're just going to pull it because I don't like it. So we're going to get rid of the tag range stuff entirely. I'm going to go ahead and even just pull the variable, and it's gone. And now again, I suspect that now we may introduce a bug with that, because I don't think we're mapping on the 0 to 1 range, so we might have one. Okay, we don't. So it's still fine, even with that change. And so now let me go ahead and go to the entity code where we're actually drawing this stuff. So where we draw this stuff here, you can see this is the code for entity output, which is massively overcomplicated at this point, and we probably should streamline it at some point, but, what are you going to do? Water under the bridge. So if we take a look at how this is mapped, you can see it here, the facing direction coming through here. If we want this to be mapped in a regular pattern, so 0 to 1, what we'd want to do there is in the actual asset import stuff, right? So when we actually import these, we presumably have like a tau, going on here. You can see when we do import body, there's this facing direction nonsense, and then we do a y index mod 4 times tau 32, right? Going in and wait, what? What is that about? Y index mod 4 times tau 32? How is that make sense? That's going to be 0, 1, 2, or 3. And then we multiply by tau 32? Isn't that wrong by 2x? Like that would have to be pi, wouldn't it? Is that anyone? Am I the only person who thinks that's weird? because I think that's weird, folks. I don't love it. Chat, hello? Is anyone paying attention? I mean, correct me if I'm wrong, right? If this is supposed to be facing direction and it was supposed to be mapped in the stupid world where people use, for some reason, pi and tau to describe circles, which, by the way, I would never do today. We did that because when we started Handmade Hero, we were not really being smart about it, and we used the stupid math way of representing a circle, which sucks. But tau 32. Oh. Oh, that was great. Oh, that's so good. It was just off the screen. Oh, that's beautiful. So, okay. Whew. That's so good. Look at that. Because I'm like, what were we doing? Like, that's not going to work. So that's fine. That's fine. Yeah. We need line overflow indicators, right? Like, we need a little thing that says there's more there. Of course, I could have told that because there's no semicolon, but... Okay. We're fine now. Yeah. It's in Star Code Galaxy. The circle stuff's in Star Code Galaxy. So I finally, like, Star Code Galaxy is my excuse to record all the things that I ever wanted to record where I'm just like, this is dumb, don't do it this way, do it the right way, and here's the right way, right? So it's all in there. But anyway, so yeah, this part right here is, like, again, so we don't really have any reason, since everything else is encoded 0 to 1, we might as well just encode this 0 to 1 as well, right? Like, I can't see any reason not to do that. So we might as well just have these go 0 to 1, and then we can just map out of the tau range on the other end, right? So to me, it seems way smarter, instead of doing this, just don't, right? Like, just don't actually do that multiplication, because there's no point to it, right? It doesn't do anything for us. So if we just do y index mod 4 over 4, that seems like a way better deal, right? You know, I just don't see what the point is of mapping these out to tau 32. So to me, that seems like the right solution. And so everywhere that we're doing that kind of garbage, I think we should just stop. So let's just stop, because it makes things a little simpler for us. So, you know, off we go. Now, this, what is this about? This looks like a just incompetence here, right? Because this doesn't look right at all. This looks like it's just wrong, because this should have been just that, right? I mean, I'm not sure what's going on there, because the facing direction should never have been time should oh, I guess I know what's going on. It doesn't need to do a mod 4 because it only does 4. So, okay. No, that's fine. And then we've got one more down here. I'll get rid of that one as well. There we go. So yeah, our tau 32s have now been sort of exercised. And I think that's all fine. So if we recompile this now, we will be mapping those tags. The problem is it won't update our actual asset files. So that's a problem. And I don't actually remember to what extent we do reprocessing on here. I think if we change the HHT file, it will reprocess those, probably. But I don't actually know. I don't remember to what extent we tried to make that work. I know that if we change the tags, that it will actually try to change it, but I don't know to what extent it actually does the HHA modification stuff properly there. So I'm not sure, because we spent some time on getting the stuff to work properly, so it's not completely stupid, but it's also not, a particularly exciting asset system. So, So anyway, if we go into the base game.hht and I just like make a slight change to it like that so it appears slightly different, I don't know if we now run if that will actually work. Yeah, so it doesn't look like it really remapped that. Well, I guess we don't know because we didn't change the input code yet, so maybe it did, but I doubt it. So we can actually go check the actual values too and see. But if these entity facing direction things right now are still on the tau front, what we can do is just divide by tau 32. And that will give us, and we don't even really need to divide. We can just do a pre-inverted tau 32 here, multiply by the facing direction, and off we go. And so that'll map that from 0 to 1 as well. So now we have the whole thing mapped on the 0 to 1 range. And that it looks good, right? It looks like it's working. So I guess we do remap the tags. I guess we're better than we thought we were. So now the only thing we have to do is go back in and figure out why the downward facing dog is not downward facing. And by the way, I like how pushing the Alt key makes that happen. Like, what is going on? It'll be interesting to find out what that bug is. Like, those are weird things, right? They don't happen in debug mode. Something weird is going on. If this turns out to be a Visual Studio compiler bug, I sure hope not, because if it is, there's going to be a big old rant. So anyway, we just want to know why our downward facing direction isn't working. And so our downward facing direction, we would expect it to be 0.75, right? Is what we would expect. We would expect its facing direction to be 0.75 when the hero is facing downward. And our question is just like, why isn't that happening? Now, if we go, first of all, just to reacquaint ourselves with what's supposed to be happening, we would expect inside our source directory where we have the actual art that if we look at a particular orphan, they all should be the same. I mean, in this case, we're talking about the hero. It's supposed to be like going down from the top. So that's 0, that's 0.25, that's 0.5, and that's 0.75. Right? So those are the directions that the hero is supposed to be facing. And I don't actually really... Okay, so people in the chat are actually telling me that there are some big code gen bugs reported and fixed lately. Ugh. All right. Well, that'll be fun. Anyway, so the point here is just that we would like to start verifying a few things. So first of all, we want to make sure that when we are facing downward, we're properly filling in 0.75 for the match element facing direction. So that's one thing we have to verify. And then we have to verify that in our actual get asset table, so in get best asset, so here, we have to verify that we actually have an entry for that, right? We have to have an actual entry for the asset facing that direction. So the 0.75 asset has to be in here as well. And then we have to see that, make sure that it's matching the best, which it should, because it should be a match index of 0.75 minus a match index of 0.75, right? So it should produce an absolute value of 0, which will be the highest possible thing, right? Because it'll be minus 0. And so presumably that will just work, right? I mean, that's the theory anyway. And we don't know, like, what's going on here, but that's the hope. So there are some of the things that could be intervening, like we're doing a total match difference here. So if for some reason, like that one particular body sprite import, if there was some other bug on the importing where it was setting the tags, where it set some other tags on that one that it shouldn't have set, then the total match value might be wrong, or it might just not even be in this hash line, right? So there's definitely some things that could be busted that we don't know. So we have really no idea what's broken, and we just have to start looking through these various pieces. Now, I hope, and I could be wrong about this, because if there really are a bunch of new code gen bugs in Visual Studio, because it's that Microsoft quality shining through, we don't know if maybe that's a problem here. I mean, I don't think it is, because we're messing with the asset tag system. So it should be our bug. That's my assumption going into it, is that it's our bug, not some weird compiler thing. But that means we should be able to build in debug mode, right? We should be able to build in debug mode, because this is not like the weird lighting thing where it's only happening in release that we noticed there. So in debug mode here, right? I should see when I swing the fist downward what looks like just trying here. Yeah. So when the hero is facing downward, you can see that you still get this scenario where it's not happening even in debug mode, which means that we should be able to take a look and see what happens in that matching process by checking out the entity. Now, there's a lot of ways we could do this, but I'm just going to use like code aided debugging here, because it's going to be the fastest thing, I think, for debugging this, which is to say that I'm just going to go ahead and say, well, look, why don't we just first, right off the bat, ask for a facing direction that's greater than 0.6, right? And that will allow me to just set a breakpoint so that I know that, there's a bunch of entities being rendered, and I don't really want to have to worry about like getting to a particular one or stepping through this a bunch of times and finding it. I just want a thing that'll like stop on somebody who's trying to look this thing up, right? And so what I'm going to do is I'm just going to make a piece of code there that I know checks for the things that I want to check specifically. And then I'm going to go try and, let me see here, entity, and then I'm just going to try and set a breakpoint there and step through and see like how that matching is happening. And, I highly recommend that kind of coding if you've never done it before, inserting code into the actual project that does a bunch of sophisticated detection potentially, and then has a place to put a breakpoint is just really handy, right? And there's really no downside to it. You can always remove it later after you're done debugging, so it doesn't really matter. Of course, that that assumes, I guess, that there is a way to actually stop the code here. So that is bad. Do we need an update or something? Did they break PDBs again, George? Anyone? It looks like we can't actually load for some reason. I don't know why. Like, debug-wise, that ain't happening. Yeah, so did they break? Wow. They broke PDBs too? Are you kidding me? So this is why, for actual work, like on my main dev machine, I just don't update the compiler. I just have a static copy of it that I like pulled out the compiler piece from, and I just never update it, right? So, George, if I update Remedy, will I be able to set a breakpoint or not? This is not the latest. Do you think if I updated to the new one, we would be okay? Because I can do that right now. Should be able to. Okay, great. Let's do that. All right. I am going to go ahead and grab a new remedy. then, that is as soon as I remember where the thumb drive is. Here it is. So I apologize for taking a quick break, but we will need to grab a new Remedy BG from the illustrious itch.io. Always a pleasure. And let's see. Do 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 do. Da 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 da. This is the music, by the way, that goes with Handmade Hero. Da 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 da. Okay. So I have now downloaded. I also grabbed the new copy of 4Coder because I saw Ryan saying something about the fact that it exists now, I guess. I don't actually know. So I tried to grab both of those, and now I will poot over to the other machine. Let's see here if this worked. I don't know if it did. And we can try to grab. I won't try to grab 4Coder because that's working fine. Like, we don't need to muss with that. But I will try to grab the new Remedy. So here we are in Apps, Remedy, and we will close that down. And we will delete this one because we don't need it anymore. And we will overwrite those, replace. And now we have a new version of Remedy, in theory, anyway. And we'll deal with this later. So now, possibly, if I rerun Remedy, maybe we will be in a good state. I don't actually know. Looks like I have to open my save file for some reason. Okay. For some reason, everything has been rearranged, and I don't know why that is, but we'll just assume there's some reason why that is. And I'll try to reconstruct this stuff at some point, I guess. I don't remember how we had it. But at the very least, it's probably something like this. The watch window was up here, presumably. This stuff was down here. And then I had the disassembly somewhere. There it is. And that was like probably down here, would be my guess. And I don't know that we ever used the register window. On stream very often, but you know. All right. Maybe I'll put that down here. All right. So that seems good. I don't know how do I save this? Can I? Because I guess it got. You know. Can I save this here or something? Save. Handmade Hero. Like that. All right. So we're just going to assume that that's good. We don't know, but we're going to assume that that's fine. And we are then going to go try to get this thing to break in the piece of code that I created that is the breakpoint. So right there. And it doesn't work, apparently. So I guess we're just, I guess that's the end of it. And that means we don't really know that could be Visual Studio, I guess. Because we're running the right Remedy now. right? This is 333. So I don't know. I can force it to break there by just doing a, an int 3 or something. But the problem with that is presumably if the PDB isn't working properly, we wouldn't be able to step through the code. So it doesn't actually matter that's the case. So I'm not sure that that'll help, but I mean, I can try it, right? I think that's the MSVC intrinsic for that. I don't actually know. It's been a while since I've typed it in. Whoa. What is going on? There's just some really weird things happening that are just super strange. So the debug break there does not trigger, even though I would think it would. I mean, unless it was actually getting set to like negative pi, so it never actually goes over 5, which could be possible. So I guess I'll just, I mean, let's just make sure that anything's working. So this should, anytime, if any entity can render at all, it should break. Right? Okay. So, oh, hey, look, and I can actually, so it looks like I can actually debug this now if I debug break in it. Well, that's a good sign, right? I mean, that's a plus. So let's take a look here. So for some reason, we never actually break in this routine, which would explain why we're never picking that element. So I guess the next question would be, like, how is facing direction getting set in that case, right? Like what are we doing for facing direction? It must be getting set to like a negative value or something, such that, we can't ever pick the higher values. So let's find out, because I don't know what's going on there. So facing direction. I mean, that's pretty obviously setting it to what we want for, like, the orphans, for example. And you know what? So strictly out of curiosity, what's happening with those orphans? Like, how is it possible that if we set this to 0.75 times tau, how is it possible that we're not getting that? Like, what if we hop over to one of those orphans? Like, what do we see? Like, now I'd have no idea. And, like, the orphans aren't there? Curiouser and curiouser. Like, that's where the orphan would be, right? And so that's pretty weird. Did we turn off orphan placement or something? Because, right, that would be, this would produce the orphan, and the fact that we have a conversation area, right, would seem to suggest that the orphan must have gotten placed, right? Like something's pretty off there. If I go to add orphan, which is in the entity gen, so this code here, it sure looks like there should be one, right? I don't know, man. This is getting weirder and weirder. So, all right. So that seems weird because we should be at least getting orphans placed at facing directions 0.75 times tau, which should have mapped to 0.75 when you multiply back out tau again. Well, we divide by tau, right? Like, effectively. So that's very suspicious. Like, I don't know what to make of that. But it's weird and I don't like it. So let's go ahead and I guess look at what the actual hero code sets the facing direction to. So, okay, so that would be the explanation there, probably, right? For no real reason, we're calling atan2, which would map to like a negative, right? Because atan2's range is not 0 to tau. It's negative. It's negative pi to pi usually. So that's probably why that isn't working. But why the orphans aren't there, that I don't know. So we're gonna have to figure out why we don't see any orphans. That doesn't really make good sense. So yeah, facing direction wise, I guess that to me suggests that if we're going to treat that as our facing direction range, which is fine, then this needs to be remapped so that basically, like, you know, there's something along the lines of probably this. So we'd take this thing and we would check to see if the facing is less than 0. And then, assuming that the facing is less than 0, we know that we actually want to map that area, right, that was less than 0 to the region that leads up to 1, right? So assuming it's less than 0, we know that now, because we did 1 over tau 32, we're going to get like 0 to 0.5, and that'll work properly. But then instead of getting 0.5 to 1, we're actually going to get 0 to negative 0.5. So we just need to start, right, at 1 and subtract what we were doing before, or I guess I should say add because it's negative. So as you get more and more negative, you're just sort of subtracting away from 1, right? And I believe that should be what we actually need to make the facing direction be proper there, right? What's the warning? Oh, sorry. So that was all we needed, and now you can see that it's correct in debug mode here. So that's all good. But we still don't know why we're not seeing any orphans, right? So where did our orphans go? So let's, before we go any further, let's go in there and see like where all our orphans gone. Because, you know, there's orphans in each one of these rooms, in theory, has an orphan in it, but we don't see any orphan. Now, that could be because the tags on the orphans are wrong, in a sense, meaning that, like, you know, that would be why they wouldn't be drawing anything. But we had a debug break in here, and we didn't actually ever see it hit, even though their facing direction clearly should have been possible for that to occur. So that's a little bit weird. So I'm going to try setting another debug break in here just for fun. What I'm going to do is I just want to see if we get a orphan, something that we can identify as an orphan. So when we do, trying to think of how to do this, the brain, when we set the brain to these in the place orphan call, so, or add orphan, I should say. When we place the orphan here, so there's even more things that are weird. So this is supposed to be a collider. So it's supposed to take up space, right? And you're not supposed to be able to walk like where it is. So that's a little weird too. I don't know what to make of that either. There's just a lot of weird stuff going on here, and I'm not sure how to assess it. It's very strange. So we want to probably look at this code and see, like, maybe we just set a breakpoint and add orphan, assuming we can step into it. I don't know if we can or not. But assuming we can step into it, we probably want to just see why can we walk on that square as well. So that we might have other bugs, but we'll see. So let's start by assessing the tags first. So what would the tags be here? There's an asset body and an asset head for the orphans. And if we look at the place orphan call, it looks like the way this works is it has an orphan tag name associated with it. It adds the orphan tag, and then it doesn't add the orphan name tag anywhere. Okay, it does at the very end. So it adds the orphan tag and then the orphan name tag. And so when we're doing a place orphan, you can see that there's like a bunch of them. So if we look back at the HHT, I'm now just going to look to see what's actually going on here. So for the... Okay, I think I see what's going on here. So the problem here is actually pretty simple. So I think what we're seeing is the actual bodies. So here are the heads, right? But the bodies don't line up with those, right? So we probably just need the bodies to be the same names as the heads is probably what we need to do here. So what we want to do is go to, like... I'm assuming that they're numbered the same. I don't actually know. But if they're numbered the same, then probably what we do is we just go to, like, head orphan, and we just look at what we labeled those. So, like, head orphan 1 is Sunny. So we just say Sunny. 2 is Lambert. Then we have Carla. Cassidy. Drew. Klein. Giles. Slade. Brom. Baby. Viva. Dylan. Rhoda. And Laird. All right. So yeah. So assuming, okay, cannot find build.bat. I don't know why we're having trouble with that either, with the build.bat. But it must be because it's not in the right direction. I don't know. Who knows? So anyway, if we go ahead now and run it, I would suspect that we probably will have orphans. I want to take a look though at this in release mode. And then we kind of still have the problem of like what's the weird stuff that's going on with the lighting. So we don't really know like where that's coming from. So we're gonna have to take a look at that obviously. But so if we take a look here, that's so strange. I don't know what's going. That must just be a really bad bug. So now we should have orphans, and luckily we do have orphans. Right, you can see them there. And if we look, the only weird part is they're facing the wrong direction. So that's a little strange, and I don't know why that would be because we looked and it looked like they were pointing the right direction. So something's up with that. That place orphan thing is placing them in the wrong direction. We also now, in theory, so if we want to actually add the proper connections here, we can. So they can have the heads as well. If we do an add and we do a placement. So I don't even really remember how this stuff works. So this is base of neck, right? And we can like adjust where it is. Like I said, don't really remember very much about how this stuff works. But if we swap between these, right, we can add the, I guess, is it top of head? No, it's just default for this one. So I don't remember how this stuff works at all. I guess this is like the connection on the thing, but I feel like I thought we had a way where we could see it, right? Where we could actually look and see, but it looks like we're not drawing those squares properly. That's probably part of the weird rendering bugs we're experiencing. But so we don't really know like where the placement point is on this thing, which is a problem. So we're gonna have to debug that. But like I said, we can actually have orphans now, which is nice. So the problem at the moment, anyway, is separate from all of that. The facing direction here is like obviously wrong. You know what I'm saying? So we said that they were supposed to be 0.75, but that's not the facing direction they actually have. So something's up with that, and I have no idea what. If we look at place orphan and there's this result facing direction thing here, I don't know if like maybe this is getting overwritten somehow, right? You know, who knows? So when this gets set, and I don't know, maybe it gets the place entity stuff overwrites it or something. We could try stepping through this and seeing does somebody get does somebody like overwrite that in some way when it actually goes to place the entity? Like, does it even use that? And you know, or does it forget to use that or something? So I believe in the room gen, that's where this happens, where it goes through and places the entities. There's like, right, like in here, you can see it finds place to place entity, puts the entity down. Here's where the thing happens, right? The entity gets placed. And, you know, yeah, like it doesn't seem like anybody does that. Right? So yeah. It adds the entity, it sets the facing direction, but you know, this is already an entity, so it feels like the facing direction should just be used there. Is it possible that the facing direction is not packed, is not saved? I mean, I suppose that's possible. So if we look at, like, if we look at where this is actually being processed, so it looks like we're really not talking about this value in very many places. This right here. So that's not used, right? So that's wouldn't be an issue. We don't care about this or that. So yeah, I mean, I don't know why that would get overwritten anywhere. This all looks like basically that's for the snake, so we don't care about that. This is for the hero. Yeah, so I mean, I don't know why that would not be set properly, right? Cuz no one clears it, and I don't see any reason why it wouldn't just work. Right? Like I don't see the point. I don't see the point where that would get undone. So I would have been expecting that to come through properly, and it's obviously not, because if it were, we would be seeing the entity pointing downward. I don't really see much of a way around that. So let's go ahead and see if we can find out what the heck's going on there. Let's switch to debug mode, and let's step through, if we can, the place orphan call, for example. Just, step through some of this if we can. I don't know if we can. Yeah. So it's like only that file, or only the setting breakpoints in that particular file was a problem, which I'm not sure why, but it just looks like something was wrong with that. So in here, here's us setting this thing. If we look at the entity that we create, it's got a facing direction right there. It's setting it pretty much exactly the way you would expect. So there isn't anything particularly weird going on there. And then when we place the entity, it doesn't look like it modified it at all. So that, still looks pretty much correct, right? Like I mean, I just don't see anything particularly weird happening there. So I can't say I would know what would be going on. I can't say I have any idea like why that would be a problem. So if we go back here and try to set a breakpoint inside the entity drawing routines now, and we just look, I guess, so somebody is like wiping that facing direction at some point. Somebody's clearing it out, right? And so I'm assuming that if we went in here and we set a check where we said if facing is greater than 0.5, debug break, this is what we did before, and I'm just assuming we would, even though we know we should see it, we never see that, right? We never see that case get hit. And so I have to push downward to get it to go, which is what we would expect, right? So now let's try hopping up. I won't push downward. Let's try hopping up to an orphan, and we won't see that case get hit, I assume. And so then at that point, I don't know, maybe we set a data breakpoint and see who clears it. Because I don't know why it's getting cleared. It doesn't look like anyone should be able to clear it. I mean, and there's our orphans, right? They're right there. And we can see that they're pointing the wrong direction. So something is weird there. Yeah, that's a mystery. So what we need to do now is, just see if there's some way that I can check to see why we're getting that clear. What I might do, like I said, is just see if I can set a data breakpoint there where we can go in here, we can look at the result facing direction, which is this, and just see if anyone wipes it out. So I'm going to try setting a breakpoint, and let's see. I need to know the address. I don't know if I can actually take the address here. Let's see if I can. So result facing direction. Did that work? I mean, it might have. The only problem is I need that to be, well, hopefully it just kind of snaps it and it stays. So I'll try. Okay. So it does get cleared. And so, you know what? I think I know what this clear is. Didn't we introduce a clear in the entity system? So you can see if you look at the entities, did we put that below the line? Perhaps? Because here's the clear, right? No, it looks like that's above the clear, though. So, all right, well. So who is this? Let's look at the call stack. Here's 0 size, push size. So this is just reclaiming. So this memory is getting vaped, which makes you know, it makes sense, right? Because that just gets pushed into permanent storage. Like that's just temporary scratch storage, and it's going to get moved. It's going to get copied right into the backing store, the world chunks. And when it copies it into the world chunks, you know, we don't. At that point, this version of it will just get thrown away. So this is actually exactly what you would expect. So that method of tracking, it's not really going to work. We would need something that actually followed it through, right? But at least we know, you know, that is happening there. So, you know, do we have some kind of bug in the chunk stuff maybe? Like where we forgot about something we were doing, where the chunks get pushed on and they're like not copying the whole thing or something. So like the packed entity size, right? Something like that. So I don't know. That's like one option. You can see discard everything after is like, it's right here, and it's just getting rid of this stuff. So really, yeah, I mean, it doesn't look like there'd be anything strange going on there. Doesn't look likely. All right, so I can't think of any easy way to debug this other than to start to track the entity through to see what actually happens to it. So like we'd track it on when it gets packed back up. And we'd look at what the facing direction was, I guess, right? I mean, I can't think of anything else to do. You'd track it, you'd see what the facing direction was. When it gets packed, and then when you unpack it again. So each individual time, right? We would do that. And so I'm just gonna do that because I don't see a shortcut here. We're just gonna have to check. So I'm gonna go ahead and just do like, you know, that. And when we go to create an orphan, since all of the orphans are broken, right? There's no, it's not like only one of them is bugged out. I'm just gonna say when we go through and add these orphans, they're all just gonna have debug set to true. So any orphan that, you know, oh, it is, it is a fake entity. Okay, well, that's the whole bug right there then. Okay, so those do create gen entities, which just have a temporary facing direction, which we didn't copy when we actually create the thing. All right, well, so that was stupid. It's just been too long. Just been too long. since we did this. That's pretty much it. So never mind. Never mind about it. So that's all. It's just when we're placing these entities, when we look at these gen entities here, get entity at traversable, I guess this picks it. Wait, but when does this actually work? So we go through the entities, we find place to put an entity group, we query, we loop through them, we then try to get the entity at traversable, but how does that work? Pending entity creator. Oh, it's gen entity at. Wow. So I thought that said get. My eyesight's so bad at this point. So that was the whole thing. When I read that, I thought it was just querying entity, but that's actually the thing that generates the entity. So that's the problem, right? So when this says gen entity at traversable, it does the generator, right? And it's supposed to, I assume, do this. And it just wasn't. Right? It's the gen entity call though. So it looks like we don't have to actually even pass that. So I guess it has to be done out here. Like that. Looks like. Okay. So I think that solved our quote-unquote bug, which was just us being stupid. It's not much of a bug. So I think now we're just down to the whatever that very strange sort of spooky lighting bug that only happens in release mode. That people in the chat are saying Visual Studio might be implicated in, which I hope not. I hope it's just our bug. If it's a Visual Studio bug, I don't know what we would do about that exactly. But I guess that's where we're at. So we will go and start looking at that. But yeah, since it only happens in release mode, that's going to be a real pain in the butt. But that's where we're at. Okay. So now we're good. That's actually the correct thing. Let me take a look and see if I can... So there's the base of neck put in there. Again, the problem that I have here is I just don't know. I can't see the little squares. So we should probably go debug why we're not seeing those little cubes. Oh, right. You just have to turn to debug camera. That's it. Okay. So let's go through and like actually put in the alignment points for our orphans so that when we hop around, we actually have our orphans because, you know, why not? So I'm going to go in here. I'm going to edit this. And so if I add the alignment point here, that's the alignment point. I should be able to place it like right at the base of the neck, which is like there, right? And this one now needs like a top of head placement, right? And that goes to the parent, doesn't it, right? Yeah. Oh, not top of head. Sorry, default. Yeah. And those should be aligned kind of like that. Probably. I don't know. Probably like that? I don't know. And then we can save this stuff, right? So we just hit save. Yeah. And now, so I think like that little built-in editor that we made, you know, that seems to have worked okay, right? Those look about right. Um, and now we have our orphan, right? It looks like that's a little off though, right? Like the place where the head is placed looks a little off because you can see the neck doesn't quite work there. So I feel like we want it to be down a little bit maybe. So let me. I'm not sure who's more the problem there, but probably this one. I'm not sure how we're going to deal with that. It looks like, you know, they're going to slide a little bit too much relative to each other. We haven't really thought much about this, right? But, oh. And that looks, yeah. uh, That looks like that's too high as well. So, like, yeah, okay. So I probably screwed this up a little bit. So that's the placement there. This maybe needs to be done slightly differently. I'm not sure how that's supposed to work, though. Yeah, I think I don't quite get it. Like, this is offset a little too much, isn't it? Or maybe not. My recollection of how this system works is not great. But, you know, these 2 points are for aligning um, the different boxes here, right? So you can see me showing the different pieces of this. So this is the base of neck point, which is where that's supposed to like attach. This is the attach point for this thing. And the offset is for making sure they move at sort of slightly different rates, but I just don't know. Like it seems like you also need like an offset parameter, which we don't actually have, but I don't know. So I'm not sure what we really do about that. Like it may be that this was just not quite right. I don't know. It may be that that needs to be lowered more. Um, but again, doesn't seem like this would work properly because no matter what I would do here, I don't see how that's ever going to produce a reliably aligned thing. And you know, because as you move to the side, right? I mean that looks pretty good, I guess. I don't know. But it's tough. Fake 3D is hard, right? I mean, hard from an art standpoint because it's hard to make it look 3D when it's not. So all right. And we don't know. Maybe that's good. Seems okay. Gonna need more light. Can't see our orphans. They're in the dark. I mean, it sort of works. I'm not complaining. Much. Too much. Okay. All right. Yeah, save. Okay. So, yeah, did that work? Did it not work? Who the heck knows? But that's what we're going with. And, oh, it looks like there's more. I feel like the scale is not right on some of these too, so we probably should we probably should also be like setting the scale of some of these differently than they are. Which I'm not exactly sure. I think the scale of the actual orphan gets set in the actual code somewhere because it's like how big the entity is supposed to be. I don't really remember, but you know, that seems like maybe something we need to do, but anyway. Yeah, that seems fine. And so there's some more orphans. How many orphans did we actually place in here? We placed a lot of orphans. So wait, did I miss a bunch of orphans then, potentially? Were there orphans down in these rooms too? No. So there are not orphans. There are not orphans in a bunch of these places. For whatever that's worth, which is probably very little. So, where are the other orphans? Wasn't there like a baby? Didn't it say place a baby somewhere? Maybe we didn't actually place the baby anywhere. I thought the baby was placed somewhere. So, I'm not sure. All right. There we go. So, I think we've got our orphans though now. So that's nice. And that should all be saved out. So in theory now that'll just work. And it'll be good. And oddly now, similarly, like for some reason we don't have the light bug happening. Is there some weird thing where like the fact that we were picking a non-existent bitmap forced the graphics card to do something bad, and that's why the lighting was busted? I mean, it's possible. You know, I'm not gonna say that that's particularly likely, but you know, I mean, it could be, right? So it looks like everything is nominally working. We have our orphans, we have our weird little, you know, skull dudes. We have some crappy lights that we have placed there, and you know, that all seems fine. Yeah, all right. I mean, seems all right. Everything seems to be working okay. So, how much time is left in this stream? That I may wrap it up for today because I guess that's basically everything that we were trying to do. Is there a way I can provoke this lighting bug again? though. Somehow I don't seem to... There we go. So I guess we can start looking at that in the time we have remaining. Because I'm like, we didn't do... Like, it should not have fixed that, right? Like, that seemed weird. And so I don't understand what's going on there. And it's very peculiar. Like, now it's just in that state. And now it's not. Right? Like what is going on? It's very strange. So I'm not sure exactly what's happening there, but I do think that, that might be something that where we would benefit from running under a graphics debugger, so we could see like what is happening there. There might be some fairly obvious stuff that's going on there that we could fix, right? But it's definitely like a weird kind of intermittent thing that I don't know what is actually happening. Like why is that happening sometimes? And it's very, very strange. And you can see that it's like a massively overbright. So it's like the lighting has air, like nans in it or something. Like something weird is happening there. And I don't actually know what that's from. How much time do we have? I think we have like 30 minutes. It's time to stretch. Everyone stretch. Stretch right away. Stretch. Stretch. Everyone stretch. Red Unlock said, if I remember correctly, this bug was introduced when you added the fade on load. What fade on load? There is no fade on load, is there? I literally have no idea what you're talking about. We don't have a fade on load, do we? It also kind of seems to like... Yeah, I mean, there's a number of ways we can now start to track this down, right? So let's see. So we don't anymore store any lighting stuff in the entities, as far as I know, right? You can see that this stuff we don't really have anything stored in there. And if we look at like where the sim region and world chunk stuff like pulls stuff in, I'm pretty sure we don't have any like we got rid of the stupid stuff where we were tracking like lighting entities, I think. I don't know, maybe we didn't, but I hope we did, because I thought we did that. So in like begin, world change, ensure region is unpacked. So it looks like... Yeah, it looks like we don't do any of the like stable entity slotting or any of that stuff anymore, right? So don't think there's anything implicated, like, I don't think there's anything implicated with storing these entities or like having them persist stuff, because we got rid of that stuff because we don't actually need for our lighting system no longer requires any of that. So I think that's all gone. And so we're really just talking about the lighting being, being in the standard way that's getting pushed down. Like something is getting screwed up in there somehow, right? And we just don't know how. So yeah, I guess what we should probably do here is just add a bunch of debug checks to put in debug breakpoints wherever we see like a lighting value go to some ridiculous thing. So like maybe check like maybe we just want to start like adding some lighting debug checking where we can look through it and just see, what is there weird stuff happening, right? So I don't know. So let's take a look. Um, So I guess I don't know. Yeah, you can see us here. One thing that would be interesting to know is like, does this have any differences in terms of like whether or not it's threading or not, right? Because this is the type of code where you could have threading bugs pretty easily. If we take a look at like where we call internal lighting core, you can see here where it passes the lighting queue right here. If we were to like vaporize that, that would prevent any multi-threading. So we could also see to what extent it might have something to do with the light, with a multi-threading issue. I'm not sure why it would, because the threads don't really communicate with each other in any particular way. So I feel like we should be able to get this to reproduce itself even without the multi-threading, but you never know. So if we do lighting queue equals 0 here and recompile, this will single thread the lighting. And so it will be much slower as well. But and I could believe that there was some kind of weird threading thing going on there. Because the reason I say that is just because there's a couple different things that can happen in debug versus release builds. So one thing that can happen in debug versus a release build is that there's actually just a code gen difference, and that's the problem. The other thing is that a debug build is much slower, right? So if you're talking about some kind of an obscure multi-threaded problem that occurs, you can see how maybe you would end up in a situation where if your code runs slow enough, the multi-threading race condition doesn't ever actually happen because the code is too slow to ever actually have it be a probability that it will occur. But when you then run the code more quickly, you find that it does, right? So it could be something like that, but we don't know because it's an intermittent bug. We can't reproduce it when. Okay, so there you go. So running the lighting single-threaded doesn't change this, right? We know that, so that more or less proves that it isn't that, because if we turn off the lighting queue, it still happens. Yeah, there needs to be, so someone needs to modify Insobot so that anytime anyone mentions Rust, it just times that person out for 60 seconds, right? So if you say Rust, you just get a 60-second auto timeout, right? So it doesn't look like threading is particularly implicated there. It looks like some kind of computation initialization problem is happening. Or maybe like an accumulation problem where if the time step is too large, you get some kind of a weird, state happening. I don't know. When we look at how the blending works and so on, right, it looks like that's just set to a fixed value. We're not even basing it on the frame rate or anything at this point. It's literally just blending at a noise threshold. So, like, it shouldn't matter what the frame rate was there because it's not actually using that. It doesn't actually care. So that also does not seem particularly does not seem particularly implicated. So I'm again not really sure where to start looking. So what I guess I will do is try to add something in here that just can look through and try to see if there's anything particularly strange. I mean, I suppose one thing that's interesting is like in the update lighting call, you can see that there's sort of like a case here, right? Where it does this every so often. It does this when the grid or the fundamental unit stuff changes. And you assume that only happens once at startup, but if that was happening multiple times, maybe something weird was going on. I don't know. Even that doesn't seem super plausible to me. So I don't know about that. So yeah, so if we look at where the lighting information is stored, right, we've got a thing in here where we're like, okay, we've got when we call the internal lighting core, right, we've got the light atlases that we're writing into, and what we want to do, is we would want to look at the spec atlas or the diffuse atlas, and I guess we want like a spec, like we want a thing that will loop through the spec atlas and the diffuse atlas anytime we want, and just see if anyone's written anything absurd in there, right? So we should be able to do something like in Light Atlas have a debug function, right? So, we've got these light atlases, right? And we've got the texels. Have something in the light atlas where it would just say, look, if you call this function, we go through the entire atlas. We know that's slow and stupid, but it's just for debugging. We'll make a function that will just do a validate atlas or something, where it will just go through and just check everything. And then we can just like spam calls to this like everywhere. And so we should be able to find the place where it porks out, right? So if we do like a thing that just as dumb as possible, right, just loops through everything, like the entire atlas, the whole thing, which, I don't even remember how to do at this point. But if we just loop through the whole thing and we say something like get light atlas texels for a particular location. So, I mean, maybe like this sort of thing right here. Oops. Like get tile unclamped. Yeah. So we can do something like get tile unclamped. Although actually, I suppose we don't even really need to do that. We could just say, look, we know how large it is. So if we just do like get light atlas texels, we should be able to just loop through however many texels there are, right? So if we say like texel count equals tell me how many there are, and then say like texel index is 0, texel index is less than texel count, plus texel index, right? So if we just loop through all the texels and we look at them, if we assume that these texels are all this light atlas texel, which you would think they would be, right? So if we get all of these and we just loop through them, I mean, that should do it, right? So now we've got our texel. We can just do like, all right, so if we look at the red, the green, and the blue channel each, we should be able to check to see if these values are sane, right? So we pass a component here, and we can just say, like, if C is less than 0, or C is greater than, 1,000, right? If either of those two things is true, then we can stop, right? Like, I think we have a... Where's our assertion? I don't even know. Yeah, then I'll just do assert. Horrible. Very lousy, stupid code. You are not programmer. Learn the variable. And so in here we can just say, all right, let's validate these components. Each of the components of the texel. Something like this. And in theory, that should just die immediately whenever we hit something that's broken. It is .value. Oh, wait. So that's not quite right. Sorry. So light atlas texel here is actually a thing that it retrieves when you do this. So actually, these are just v3s. It's more like that, right? So I don't know. I think that is roughly what we would want. Not 100% sure because I just kind of hacked that in there. It's been a long time since we looked at it. But basically what we want is something like that. I can now go in here and throw that in and just see. I mean, we could just now say like, all right, so take the spec atlas and the diffuse atlas, do a little build, run the code, and now, yeah. So, I don't actually know if this is working or not, but hey, it just triggered, right? Which is good. And so, in theory, we can see like we have the ability to detect when it actually happens, right? Now, we don't actually know that that's true because we don't know if maybe that just triggered unnecessarily here, but it looks like it at least sort of did. So another thing we could do is make it so that we can continue running after that happens, so that we can see. I mean, I guess here's what I would say. Like maybe we change this slightly so this is like a B32, and the result is like something like this. And then we say, okay. Oops. I don't think you can actually do that, but I can do this. So we just like and all this crap together, and then we return. So now what we would do is when we do, oops, I don't know why I typed that in. So now what we would do is when we validate one of these things, it's basically just going to say, okay, tell me one way or the other if this worked or if it didn't work. And then we can take some action based on that. So like if validate atlas, right? Like if you can't validate the atlas, we do something. And so one of the things I could do here is just add some kind of like, you know, break, right? That's not right. It needs to be in both of those. Okay. So if we can't validate the atlas, we need to like, maybe we could just print something out. You know, we could do like an output debug string. I don't know if I can actually do that here. Can I? No, I can't. If we just put forth something that says that the atlas is busted, like using a debug out of some kind, right? So in here, we could do a debug value, which is just, do you think the atlas is valid or not? And, you know, like some stuff happens and then a thing and whatever. So, if we, for example, put in the lighting panel just like a thing that was like, could you validate the atlas or something? Like, suppose we did this. Spec valid. Diffuse valid. And again, all I'm trying to do here is just make sure that this trigger actually does work, so I can visually see that the trigger happens at the same time that the bug happens. That's all I'm looking for. So now, in theory, like, if I look at the lighting system, you can see that it says that it's valid, right? And it just switched to non-valid, just like that. And of course, the bug hasn't happened, so that seems bad. So I don't know what to make of that. There's two possible reasons for that. One reason is that actually these bounds are too tight. Like maybe like it's occasionally negative here or something, right? The other possibility is that there's actually invalid values floating around out there and they just don't contaminate things normally. So it actually was that actually is catching a problem that is actually related, and we should pay attention to it. And I don't know which of the two it is, unfortunately. What I will do here is widen the zero bound more. I'll make these more ridiculous just to see if it still happens, right? And so I'm just trying to provoke it there a little bit, and we'll see. All right. So literally just doing that, it changes sometimes, right? You saw it change to 0. And I have no idea why, right? But we really should not be seeing lighting values in that range, I don't think. Unless I'm misremembering, like, how this system's actually functioning. It is true that the spec atlas is, like... I feel like the spec atlas is... No, the spec atlas is persistent. So I feel like it should never be out in that kind of ridiculous range. So I do think that's indicative of the fact that there's probably something bad going on where some values, like on the edges or something maybe, are busted. So let's suppose we do again, like maybe we check a tighter bound now and see it should be 0 more often. So there's a couple of things going on there. So yeah, maybe the check is bad. The other thing I was thinking is, it might be that we don't compute the entire atlas every time either. Like, I don't remember if we intentionally leave some of the atlas unprocessed, but it is kind of true that like, assuming that I'm checking this properly, it seems like we maybe aren't processing all of our textiles the way we should be. Like, something seems busted there. And I'm not exactly sure I know, why we would ever be actually getting those problems. Like, it doesn't seem like that doesn't seem sane. And so something's up with that, and I don't know what. Yeah, I don't really know. Also, our trees are missing. I guess we should go fix that part of the for the tags as well. Does our intro still work, by the way? I haven't checked it in a while. It doesn't look like it does. So our tags for the intro are also busted. So we should probably finish the tag stuff. We can do that starting next week. So the trees and this are both missing, and then we have the lighting bug. And then I think we're back to good. And hey, we also have our orphans now. We should also put our furniture in and such. We'll start decorating the orphanage. So yeah, so I don't know. Those tags don't look like they're working right on the intro as well. So we'll have to take a look at that. Let's go ahead and do Q&A for now. Stretching. Yes, so it depends what you mean, Mex Trucks, about rendering the computed light bounce into a texture. So at the moment, we just do the lighting on the CPU. We haven't ported it over to the GPU yet because it's not really quite as good as we probably would want it to be before moving it over there. Um, Although obviously we would get a pretty massive speed increase probably if we did. But um, so we don't render the computed light bounces into a texture in the sense that we don't use the GPU to do it. But we do render computed light bounces into a texture in the sense that we do use the CPU to generate a texture that has the light bounces, right? So depending on what you mean by the question, the answer might be yes or no. But the process is we have CPU side lighting that does a bunch of bounce lighting, and then it produces a texture that it sends to the graphics card that the graphics card then samples for the lighting. And there's no reason we can't do that on the GPU. We just don't yet, because as soon as you move something to the GPU, it becomes even harder to debug. So, typically for something like this, I'm always going to do a CPU implementation first, and I'm only ever going to move it to the GPU at the end when I want to provide the most optimized possible path. But so for right now, we just do a CPU implementation, and it is slower. It is slower than it would be if it was on the GPU. That said, the CPU side one is not too slow right now, and it's much slower than it will be because even the CPU side one can be sped up by probably a factor of 4 at this point because it's still operating on floating point texel values, which are just completely unnecessary and massively cache inefficient, right? So when we decide to kind of bake some of that stuff a little bit more for shipping, even the CPU side one could probably be made to run fast enough when we trim out the fat. But we haven't done any of that. Do I ever suffer from decision paralysis when making a new feature? Not really, no. I do have problems if I'm trying to get a really high quality result on something though, of a similar thing, which is just that if you imagine the equivalent of decision paralysis for exploratory coding, where you're trying lots of stuff and nothing seems to be good enough, right? That is sort of similar. It's happening in the actual act of programming as opposed to the act of sitting around thinking about it, right? And the problem with stuff like that is there really isn't a solution for it. The only thing you can do is just keep working on the problem or shake up your thinking, try some crazy stuff or leave it for a week and then come back to it and see, you can do stuff like that. But your only other option is to just lower your standards, right? So if you have to ship something and you just have to lower your standards, you can do that. But there's no really other solution. The solution to decision paralysis is just start typing. Like pick something and implement it because you'll learn something, right? So there's a solution to decision paralysis. There's no real solution to I can't find an answer that satisfies me, even with exploration. There's really not a lot you can do. You can ask other people for advice. You can try some random experiments that are wackier than what you're doing. You can read a book. You can try to like shake your brain into different places to see to force you to think about the problem from different angles. But if it's not coming together, it's not coming together. So I have that happen sometimes. And when you're working on a hard problem, that happens sometimes. And so. When do I plan on releasing Star Code Galaxy? As soon as it's ready. I mean, Was the bug mostly in the start area? Once you start walking, it was better. I don't know. It seems like it's more random and hiccupy. So I don't know. George says, for the breakpoint at Handmade entity.cbp in line 295, I believe what we're seeing was the DLL wasn't yet loaded. Yeah, I don't know if I believe you, but we can check. So like here's it running, right? Let's see. And so maybe it was just like we were in a bad state just then. So where was that code? I don't remember. It was right here. All right, so it's working now. So it might have just been, I don't know why we were seeing a question mark on it the entire time, because it should have loaded like right away. But either way, it seems like it has worked itself out of that, at least to a certain degree. So that seems good, right? Can you please go into more detail about the lighting, floating point, and cache inefficiency? Sure. So what I was trying to say there was just that while we're working on developing the lighting, and until we're like, okay, we're pretty much done with whatever we're going to do there, I didn't want to try to use a more compact representation for the lighting values. Because like floating point, I mean, F32, I mean, obviously you could be even sloppier and use doubles, but like F32 is like the laziest encoding you can use, right? Because it takes 32 bits to represent a value that honestly needs probably at most 10 or 12, 16 tops, right? So you know that when you're storing RGB as three 32-bit values, you're placing at least a 2x multiplier on the cache usage, right? Every time a text cell has to be read in, you're reading at least twice as much data, possibly more. Because if you just use 10 bits for everything, you could fit them into a single 32-bit value even, right? So the way in which the lighting system's running right now is sort of intentionally probably significantly slower than it needs to be, simply because we're forcing it to process massively more memory for no real reason other than because we don't want to worry about encoding problems. We don't want to have artifacts from the way that we encode our textures at the same time that we're working on like lighting quality stuff and whatever. So it's basically just a way of reducing the amount of possible places where you can have bugs. And so that's why the lighting is currently, it's very piggy in terms of cache usage there. What's the best game soundtrack you've ever listened to? I mean, probably Monkey Island 2. Like Legend of Zelda's pretty good. like Koji Kondo music is very good, but sometimes it's hard to get like a soundtrack to it per se. Monkey Island 2, it's kind of hard to get a soundtrack as well because it's dynamic. You know, both of those are dynamic scores. So like Koji Kondo and Michael Z. Land, I think, might be the person who did the Monkey Island one. Verona Chorus says, "Hey, you mentioned programs used to debug port usage. Could you name some so I can check them out? So I could explain the execution port notation on UPs. Example 1 times POX for CMOV-L. Yeah, I mean, I think we've gone over this before, so I would search the archive. But it's pretty straightforward to do this stuff. It just takes a little learning. So, if you go to ups.info, that's where you can get all your micro-op tables from, right? So if you take a look, if you go to ups.info and you bring up the table and you look at something like you just said CMOV-L, right? The instructions will be listed on the side. They'll be listed for each type of instruction because, for example, because the x64 is not really a RISC architecture. Like, it is sort of a RISC architecture internally in the sense that the micro-ops are kind of RISC, but the actual instructions that you feed it are fairly complicated. So, for example, in a typical RISC architecture, you know, and I'm not a hardware person, so, you know, take this with a grain of salt, but if someone says to me that this architecture is RISC, then I usually don't think of instructions as being able to, like, use a memory address as a location, as an operand for anything other than just like a load or store. So you wouldn't expect like an add, for example, to be able to take a memory address that you're using to add from. But like something like x64, you can do that. Like almost every instruction that does anything like that, like an add or something, can have an operand that's like not a register. It can have an operand that's like an address in memory, right? And not just an address in memory, but like an address in memory encoded with actual like offsets and stuff, right? So it's fairly complicated. So x64 is kind of a CISC instruction set, kind of, right? And so when you talk about a particular instruction, you can't really talk about what micro-ops the instruction has. You have to talk about how many micro-ops and what types of micro-ops a particular instruction and operand set have. Because even though you take something like CMOV-L and you say, well, that's an instruction called CMOV-L, it's actually many different types of instructions depending on what the addresses were, right? What the operands were. So what you can see here is this lists all of the possible combinations of operands that you might have, like 32-bit register, 32-bit memory location. And what you can see is that the micro-op breakdown is actually different depending on which one there are. And you can see the difference. The difference is that, in general, if there's a memory operand, it has another part to it, right? So there's one part that's always there, and then depending on whether there's a memory operand as the second operand, then there's another, one here. So you first have to look at the side and decide what you're actually calling. So if, for example, you happen to be calling a 64-bit register CMOV, so the destination is going to be a 64-bit register, and the second source operand is going to be a memory location that's 64 bits, then you're looking at this particular one, right? And then the way to read this, which is the question, like, how do I read the port usage? So you've got a couple different pieces. You can separate them by the plus. Each part of this that's separated by a plus is its own micro-op, right? So when you see this plus this, these are two separate micro-ops that we're talking about here. The one in both cases and the times is how many micro-ops we're talking about in this particular category. So we are talking about 1 micro-op being issued from this category and 1 micro-op being issued from this category. And they will both be issued, right? So it requires both of them. Then you get the little P notation here. The P notation tells you which ports it goes on. So this is saying 1 micro-op that can issue on, and this is read as either. So the P with the numbers is either. 1 micro-op that can issue on either port 0 or port 6, your choice. So if either one is free, it could issue. Plus 1 micro-op issued on either port 2 or port 3, right? So that is how you read those. So if you want to know what is required to execute this, you know that the front end will turn this CMOV-L into 2 micro-ops. 1 of those micro-ops will be able to issue on ports 2 or 3, and the other one will be able to issue on ports 0 and 6. I believe, but I don't know, that this is not in any particular order. The reason I say that is because, like, logically speaking, this CMOV-L would have to load the memory operand first, I would assume, before it can do anything. I mean, I don't really know that that's true, so don't quote me on that. But you would expect, so I can just tell you, ports 2 and 3 on a Skylake processor, which is what's checked here, ports 2 and 3 are memory processing ports. So the ports 2 and 3 are used to do the load, right? They're used to like load the information into the processor. And so you wouldn't expect it to execute this micro-op first, the 06, which is the one that's actually doing the CMOV, right? You would expect this to execute first, and yet this is written second. So I don't think that these are, like, when they write it out, I don't think that these are written in order. They're just saying these are the 2 things that will have to happen, right? And they'll happen in whatever order the processor thinks they have to happen in, but I don't think they're trying to tell you that order here. Right? So, hopefully that answers that part of the question. And then the other part of the question was, like, how do I analyze these? So, like, if you go to Godbolt, I can quickly show you what you set for that. So if we take a look at Godbolt and we just say, okay, like, I want to know what the port usage is for one of these things. The easiest way to do it, because Intel has now decided to stop supporting IACA, unfortunately, even though it was better than this thing, because this thing is kind of crappy. I don't know if they've got it, made it better yet. But if you select a modern version of Clang, so x86 64 Clang, version 9 and up probably has it. I would think. I don't really know. But if you go on here and you select a version of Clang and you're compiling for Clang, you should then be able to add a tool. So in this little drop down here, where you do add tool, this LLVM MCA thing, that stands for, like, probably, I don't really know what it stands for, but I think it stands for something like micro code analysis or microarchitecture code analysis or something like that. If you add that tool, that will actually give you the port breakdown. And it's not as easy as I'm making it look, because actually it's not quite what you think it is over here. And we'll talk about that in a second. But for just in terms of, like, just in terms of like looking at how the port breakdown goes, just to start with, this is what this is what you were asking for, right? So this is a thing that goes and says, okay, here are the instructions, and this first part here, and it will tell you some stuff about, like, stats, basically. So this instruction, it's saying, is going to need 3 micro-ops to issue. It's going to have a latency of 2 cycles. It's going to have reciprocal throughput of 1 cycle. And in terms of whether or not it uses loads or stores, it does not use a load. It does potentially use a store, and does not have any side effects, right? And you can see here, like the may store and may load, these are all going to load. They're loading because of this, right? And so on. So that's the first part. Not super useful, but, it's like a heads up view, or whatever. Then you get down to here, and this is one of the most annoying things in the world, and I have no idea why they did this, but you've got ports numbered 0 through 7 on Skylake, and they helpfully labeled those 2 through 9. Like, all you guys had to do was put the XKX divider and the XSP divider at the end, and this would have worked, but no. So you get to mentally, in your head, translate the actual listing here like as if it was shifted down by 2, right? So it's like, right? But basically what you do then is you can read this, and these are the ports across here, and they line up with these. So port 0 is actually 2. So the numbers that are in here are all shifted. So P06 is actually P28 on this, right? So sucky. But that's just the way it is. This is why I say Ayako is way better. It was way easier to read. This thing's really hard to read for this reason. And no one cares. But, so we go over here to resource pressure per iteration, and what you see is these numbers here, what they represent is like the chance that the micro-op got shoved into this port is usually sort of the way to look at it. I mean, it's kind of hard to explain what it's trying to show you, but just to kind of make it a little more concrete. What they're trying to say is, like, if we were to just keep running this code like all the time, like we're just running this code and running it, where would we end up assigning these things? Like, and it's not a percentage chance, because you can see it's greater than 1, and it's called resource pressure, right? So what that's basically saying is if we ran it, right? How much is it like lined up behind this port? So it would max out like ports 6 and 9, right? And to a lesser extent these other ports. That's what the 1 in there means, right? And it's kind of hard to understand with something like this because it's not a loop. And this is where the next part comes in. So this is meant for analyzing loops. And you can see that up here. You can see like iterations, right? Well, iterations of what? Like, this is not a loop. It's going to treat your code as a loop whether you like it or not, because it's made for analyzing loops. And it's going to tell you a bunch of stuff like the reciprocal throughput of the loop, right? Which, again, you're trying to get that up you're trying to get that down to the lowest number of cycles you can, and you're trying to get the instructions per clock up as high as you can, right? Micro-ops per cycle, like I said, you can usually execute 4 micro-ops per cycle. Sometimes you can execute even more than that if they're fused, but in general, 4 is where Skylake's going to top out. So 1.61 means you could potentially, if you really happen to really luck out and you hit something the processor can do perfectly and you wrote the code really well, you could get that all the way up to 4, right? So let's see how to do the actual loop constructs. LVM, MCA, I never remember what the pound defines are. They're in here somewhere. Here it is. All right. So in here, you have to do like a thing where you stick this garbage in here. So let's suppose we actually want to do this for real. What we would end up with is like some kind of a for loop, right? So, and the for loop usually, usually it looks something like this. And so let's suppose we're doing as something straightforward. So account and value. I don't know. And we do a while count minus minus, like float results equals 0. And this is result plus equals, value. So this is just like returning like a running sum or something, right? And so we basically just wrote something, that was going to have a loop, and you can see the loop here. And, it's got like the setup code or whatever's going to happen. And then it just kind of like goes through and does like repeated addition, right? So we come in here, we do the check to make sure we should enter the loop. Assuming that we do enter the loop, we do some garbage. We grab the thing we're going to do, we add it, and then we store it back out to the stack. And of course, this is unoptimized code, so it's just going to generate a bunch of unnecessary instructions. So, we can just tell it, you can clean that up. Don't do that. Do something more sensible. And now you can see like a fairly reasonable loop. It's not great, but it's, it's reasonable. You can see we're just adding from a memory location. We're bumping, the memory offset each time, and we are then checking to see if we need to exit the loop, right? Okay. So now we got to get this thing working. This is supposed to be over here. Yeah, there we go. Hopefully that's maybe sort of right. And I'm not sure, did I do that wrong? It's saying that it's not valid. But what's invalid? What did I do wrong there? Isn't that what you wanted? Oh, right. I've got to do like a foo on both of them. So is it that? It's begin foo, end foo, right? Does that not work? Did I do something wrong? What have I done wrong at LLVM? I never remember how to get this part working. I would love for it to work, but I never really know why it doesn't work. And like I said, I was much more happy with Ayaka, and I don't know why this didn't work, but it's supposed to work somehow that way. Let's try a real search engine, i.e. not Bing. Looks like the same crap, though. I'm just going to search for those strings and see if I can find an example. Because what does it say? It says, found an invalid region end directive. But what's invalid about it? Does it not like my begin one? I also don't know why I can't see them on here. Like, shouldn't they be on here somewhere? Oh, you think I have to write the function name? Why would I have to write the function name? I mean, I don't see why I would have to write the function name. This is just all this is an identifier that tells it what the output is, right? You know what I'm saying? So let's take a look and see if I can find like something that shows how this is supposed to happen, because they probably just changed it or something since they wrote the docs, or who knows what. This is the Ubuntu man page. Okay. That's the same example, and that definitely didn't work. Yeah, Yeah. So I don't know. I don't know why we're not getting any love here from LLVM MCA begin. I mean, is it needed to be inside the brackets? It does. What? So it just wanted them to be inside the brackets, but that's not good, right? It needs to be outside the brackets. Because if it's not outside the brackets, then you don't include the port usage for the comp jump. So it needs to be there. So I'm not sure, like, and if I put it here, then it includes, it would include the enter code, which you don't want it to do. So I don't understand. And it looks like even that doesn't work. So like I can, if I put that here, I have to put the other one inside the brackets. I don't know. Maybe I can do this. Does putting more brackets around it help? Yeah. This is why I say I don't like LLVM MCA. I don't really, maybe it's just that I don't understand it as well enough. But like, this is a pretty simple thing I'm asked to do. It doesn't give me any constructive advice on why. I'm just trying to say, please do this loop. Like, that's all I want it to do, right? But it doesn't seem capable of doing that. And I don't actually know why, right? So, yeah, so just to be clear, the reason, so this doesn't really help you because that's not going to time the loop. That's not going to show the loop, right? So you can see that the only thing that's captured there is the add SS. But the problem is the loop is actually this, right? So you need it to have the end marker has to be outside the loop, right? Now we can be a saucy salamander and just get rid of the loop, right? So for example, like we could do this, couldn't we? And then we would just say, hey, like I know how is programming work a lot. And I could just say like loop top here, right? And then I just say like, okay, if you're really going to be that way and you don't understand a loop, well, I know how to write a loop because I am a programmer, right? So what I could do is I could just say, okay, put the analysis on this end of the thing and make it like go back up to the loop top like that, right? And have it just do adds. And then what we'll do is we'll just branch around the loop jump, right? We'll just say, okay, if that's what you want, then inside here we'll say, if count minus minus, is greater than 0, then go to the loop top, right? Or something. So now we've got it actually working, right? Even though it's not what I was trying to do, but, at least it maybe did something, I guess, right? And if we look here at what it actually ended up putting out, for some reason, it actually took these two. So somehow this floated up above here. I don't know. It just seems like this is kind of busted. Like that's not what we wanted. We wanted it to start below there. So I don't know. Can we make it do that? There we go. So that's correct now. But this is annoying. So you can see this is annoying. I don't love it. Ayaka was better, but it's discontinued, so oh well. But now, if you look at it, you can understand the port pressure part a little bit better, right? So now you can see, like, all right, add, right? If we take a look at what happens on the add, if you go back here, you can see that it's an add SS call. That means we're going to have to turn on SSE, right? Because it's an SSE call. What you can see here is that adds operate, right? These are the ports that they can issue on. So adds can issue on 0 or 1. This floating point add can issue on 0 or 1. And, is it a memory operand or isn't it a memory operand? Well, you can see right here, it's a D-word pointer RSI. So obviously a memory operand. So it's obviously going to be this, right? So it's going to have to issue one thing on port 0 and 1 and one thing on port 2 and 3. And like that's exactly what we see, right? So what you can see here is there's no actual full port pressure. A third of the time it expects it to issue on port 2, and the rest of the time it expects it to issue on port 3 for the load. I'm sorry, for the add, because that's actually port 0 and 1, right? Which is where the add can happen. And then half the time it will be loading on port 2, and half of the time it will be loading on port 3, right? But at no time does it actually exceed the full 1.0, so we're totally like, it should just always execute, right? We get here and we say, like, again, the port pressure, looking at where this is distributed, it doesn't look like anything sums over 1 here, so it looks like we're totally fine. In terms of the percentage time that it's actually going to execute here, you can see that this is an integer add, and integer adds can execute like everywhere. 0, 1, 5, and 6 can all do it. And that's exactly what you see. So there's 0, 1, 5, and 6. So it would just distribute out across those like this. Same with this add, right? And then you get the test, which is, again, can be executed on all those. And then the jump, right? Now, if you look at these, I have questions, to say the least. So let's start by changing this to a jump not equal. Yeah. So, because I wanted this to go down to a comp jump, right? Which you can see it doing here. At this point, let me just restate some of this stuff and then say why this is a little annoying. So, okay. So, again, what's happening here? Well, this is a loop, so we're running it over and over and over and over again. If you look at these instructions, this add, this comp, and this jump have to happen every time through the loop. The add here, this is completely independent of this stuff. So the add, comp, jump is like a completely separate thing from this. So the first time we hit this loop, it's going to pick port 0 or 1 to issue the first part of the add, and port 2 or 3 to issue the second part of the add. I probably said that the wrong way around. You probably think of it as it'll pick port 2 or 3 to issue the first part, the load, and 0 or 1 to issue the actual add, right? So we're going to, the first time through, port say port 0 and port 2 are used the first time through. That means now we come down to this add, right? This add needs to issue on a port. Well, we know we just issued something on this port, right? And we haven't even gone to the next cycle yet. We're still on one cycle. We can issue these on the same cycle. So we would issue this add probably on this port, because we know we just used this port before, and this port's free. So maybe we issue it on this. So we issue one on this port, one on this port, one on this port, right? Potentially all on the same cycle. Now, again, I don't actually know if that's true for the add, because I feel like the add probably has to wait for the memory to come back to start the add, because, you know, how else would it work? So really what probably happened is it issued something on this port, then it issued the add on the same cycle as the load the first time through, because it couldn't have issued an add, right, yet, the add SS. So it probably issued the load, not the add SS, then the add, so probably this port and this port, let's say, and then the comp has to wait for this, right? So the comp jump are now blocked, right? However, this executes in one cycle. So on the next cycle, right, If this happened to be in the L1 cache, which let's say it was, then that load will have completed, which means now it can issue the add SS, which it will do on, say, this port, because it will have issued the add before on this port, right? Although I guess that's out of that port now, so it could probably issue it on either one, now I think about it, because that will have already finished. So now it's going to issue something on one of these ports, and it will start the comp, right? Because the comp can happen now. So it'll issue the comp on one of these ports and the add SS on one of these ports, right? Make sense? And then it will go ahead, and when it finishes the comp, it will actually before it finishes the comp, it'll predict this jump. So this, honestly, this is nonsense. I don't know what that is. I don't know what that is. That looks just completely erroneous. This is not, that's not an instruction. I don't know what that means, because that's just a front end thing. That's just a branch predict. It doesn't go it doesn't go to an execution port. So I'm sorry. I just don't know what that is trying to tell me. That just looks like a bug or something. Somebody who spends a lot of time with LLVM MCA if anyone out there knows, why is it printing that? I mean, that's just false, I think. Right? So I don't know. I don't know how to get this over. Maybe I can make this a little shrinkier so you can see it. There. So that just looks like completely wrong. The JNE would be fused with the comp. It would just be something that happens in the front end, and it would be branch predicted. So either it will be completely free, or when it's the one time it's not predicted at the end of the loop, it'll cost you 16 cycles, right? So this is just nonsense. I mean, I'm not a microarchitecture guy, so don't take my word for it, but that just looks completely erroneous and wrong. Which is unfortunate, because it means it will throw off the rest of this as well, because it will assume that these ports are being used by the JNE, which they wouldn't have been. So, but anyway. But you get the idea. So basically, each one of these is kind of showing you how clogged it thinks the port will be when it goes to issue this thing, where it stuck it, right? And that's about the best you get. I don't love these. There's way better ways to view this, in my opinion. I don't like that. I don't think this is a constructive way to view it. But you can see why it allows you to spot check sort of how the parts are. So it's not useless. It's easier than writing it out by hand, probably. Modulo the fact that this stupid thing doesn't number the ports by their actual number, right? But there you go. Does that answer the question? So I generally use Ayaka, the older version of Ayaka, and then a lot of times I just do it by hand now. I don't even bother. I have a version of LLVM MCA that I use to spot check, but it's just not very good. I don't know. I hope at some point someone makes a better one, but I don't know. At some point I'll have to make my own. It doesn't matter anyway. It's less relevant now anyway, because who cares? Intel, there won't be any Intel chips next year anyway. The only things anyone will be optimizing for are AMD, because the Intel chips don't actually work. So, who cares? we can just switch the architecture here to be AMD or something, right? And off we go. There's an open source tool called Osaka. Really? That's I would be interested in that. Osaka microarchitecture analysis. That's cool. I have never seen this, but if it's any good, that would be great. Here it is. Didn't want to see that in my life. Jesus. Okay, so that's like a non-starter, right? Like I ain't installing Python. But it looks like it's integrated into Godbolt, so if you're using Godbolt, you can just get rid of the ickiness there by letting Mr. Godbolt install Python for you. I don't know where that it would be. Here it is. So, well, there you go. Off to a great start. So, yeah. All right, let's wrap it up. Let's wrap it up. Good progress today, though. We're in good shape. We'll have to start taking a look at that lightning bug more seriously next weekend. Anyway, thanks everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can play around with it yourself. You can go find that lightning bug if you want, for example. You got all week to find it. Beat me to it. I'll be back here next weekend when that is exactly what we will be doing. Until then, have fun programming, everybody, and I will see you all on the internet. Take it easy, folks.